uh, reservoir routing. This we have two parts of routing. The first part is reservoir routing, and the second part is channel routing. So, part introduction. What is the flood routing? What is meaning of this? Flood routing is techniques of determining the flood hydrograph at a section of a river by using a data of a historical flood flow at one or more upstream section. So this one, if we want to know what is the hydrograph at point B, so we can use the relationship between flood hydrograph between point A and point B from upstream to point B. From the past, for example, if you have like the hydrograph for at point A, okay, and we have the flood hydrograph at point B from the past, we can find the relationships between hydrograph at A and B. And in the future or at the present time, if we know the hydrograph at point A, we can predict what is the hydrograph at point B. Yeah, that is the meaning of it. We can predict hydrograph at point B given the hydrograph at point A. Okay. And for point A, B, it is a channel. This one is a channel routing. And point C is we call the reservoir routing. Okay, the inflow to this reservoir and flow out from the reservoir. There are two categories of routing. The first is we call the reservoir routing. Okay, and the second is channel routing. Okay, the difference is the storage. Okay, in this case, the storage of reservoir is different. Is the storage. Okay, this is storage. And for the channels, the storage is in the channel storage is very small. Okay. The routing method can be classified into types. The first type is the hydrologic routing. We use the basic equation, just only have is a bottom-line equation. But for hydraulics routing, we use many equations based on the physics. Start from mass balance or water balance, momentum. We use momentum equation, and the finite from differential equation is a Sen-Venance equation. Okay. The basic to understand the routing, you have to understand what is a flood wave. Flood wave is moving down channel with the speed u. So, for example, this is a profile of the channel, and at T1, T0 is uniform flow. Once the mass of water flow to the channel, there is a wave, T1 wave with the speed u, and this wave with this speed will moving at T2, T3. The flood wave is moving with speed u downstream. Okay. And next, if you want to understand this wave speed, we have to, and relationship between wave speed and water speed, we can derive the relationship by look at the river profile and the relationship between the flow velocity and the flood wave velocity based on this equation. So if the u is flood waves time difference between 2 points, so this 1, 1, 2 is mean two sections. This okay, and is equal to the change of difference of the flow velocity between. It should be, you can write A1V capital V and A2 V2. Okay, relate to the V capital V1 and V2, and this from our equation dq equal to u dA and dA equal to w dy. Okay, one for the width, w is width of channel and y is depth, and we can derive this equation. And the next we combine with the chassis equation from the hydraulic. U is equal to c square root is. C chassis coefficient, I hydraulic radius. What is hydraulic radius? You can remember this is a flow in the channel, and if you know the area of the flow and know the weighted parameter P, radius equal to A divided by P. It means flow area and divided by weighted parameter of the flow of the channel. Okay, and S is channel slope, and substitute V in the both equation and integration. Okay, and we got this Q, equation of Q. And assume that if the width is very large compared to the depth, almost equal to y and a equal to w times y, we differentiate both equations respect to the depth of channel. Okay, so we can get like dy over dq equal to 3 over 2 w times velocity. Okay, and make equal between equation 19.2 and 19.5. So finally we got this relationship. Prove that the flat wave velocity is equal to 1.5 flow velocity. Okay, so why the flat wave is moving faster than the flow velocity. And this show the different hydrograph from different point of the channel. Let's say from point 1 upstream compared to the in the middle and at 3.3. So we expect to see the hydrographs like this: point 2, point 1, point 2, point 3. In this case, it means that if the unit of the Q is in terms of the depth, let's say millimeter per day or something, so we expect that the peak of the hydrograph is smaller come to the downstream, and base time is larger. Okay, and if you want to predict the hydrograph at point T is not easy, because there is effect of the combination of the flow, okay, from tributary, and also there is a lateral inflow from the floodplain to the flow. So if you want to predict the hydrograph as point 3 given the hydrograph as point 1, so it's not easy to do this.